all. Welcome to this Samvaad talk. So I would like to introduce Professor Dinesh Babu Jayagopi. I'm pretty sure everyone knows this, so there is no need to introduce because he was conferred with the National
Teachers
Award for Teachers 2023 by the Ministry of Education, right? But we certainly have been celebrating this particular occasion for quite some time till now. But as we all know, it's not just one day workout. We should understand the path traversed by Dinesh for all these years. So I'll just give a brief biography on that note. So Dr. Dinesh Babu Jayagopi is an associate professor at IIIT Bangalore. Prior to joining IIIT Bangalore in 2013, he was a postdoctoral research fellow at in Social Computing Lab, IDEA Research Institute, EPFL, for about 2.5 years. Prior to that, he had done his PhD at EPFL itself. Okay, so before joining for his doctoral studies, he was working with Mercedes-Benz Research for about 3 years after his MS Engineering by Research at IISc. So his research interests are audio-visual signal processing, applied machine learning, and social computing, to mention a few. Okay, he leads the Multimodal Perception Lab at IIIT Bangalore and has received funding from several government organizations and the industry. His team has received several outstanding paper awards. I don't want to elaborate them in the interest of time. So today's talk is titled Human-Centered Vision and Graphics. So we look forward to learning more about this topic from Professor.
Thank you. Thank you, Vinod, for the generous introduction. And it's an honor to present to all of you. So today, in today's talk, I'll try to elaborate some of the contributions from the lab over the years. And interestingly, in the last few years, at least last 4 or 5 years, we have, our specialty or our area of work is on the analysis side, analysis of multimedia and so on, and particularly with vision as our important theme. But we have started to look at this intersection of, say, vision and graphics, or vision for graphics, which is a interesting development, I would think, because in some sense, these are inverse problems, right? So in vision, you have an image and you want to understand the image, right? Maybe you want to reconstruct the scene, the 3D scene. You have a 2D projection. You want to understand the scene in 3D, which is basically a reconstruction problem, scene reconstruction. In a human-centered fashion, it could be maybe reconstructing a human, a representation of human body in some sense, right? Maybe the mesh of a body and some texture and so on. So that is, say, vision you want to analyze, right? And graphics is about, say, producing an interesting image, right? And there could be characters which are rendered, and sometimes they are rendered in real time, and so on, right? So graphics has its own journey in some sense, but the eventual goal of graphics is to produce images or videos, right? And in that sense, the inverse problem of vision, which is, say, you want to generate images, right? It's a problem which is very close to the graphics problem, right? Generating images or generating videos. And there has been a lot of work in generative AI, broadly speaking, right? Where you're trying to generate images, and these images are starting to look realistic and so on. Okay, so there is this confluence of vision and graphics, which is an interesting development. Okay, so the first part about our lab and our journey within this area, right? And then the second part where vision is helping graphics and graphics So the theme will be a little bit on vision and graphics in the second part, where we have started to do some work, but it is still early days. We hope to contribute more to this area. As Vinod pointed out, this has been the journey, say, till postdoc and stuff. And interestingly, I've tried to sort of highlight some of the technical problems in which I got a chance to work, be it analysis, synthesis, adaptive filters, filters that you can learn, computer vision for accident-free driving in cars, meeting analysis, I'll talk about it a little bit more, human-robot interaction, right? And apart from that, during various experiences in these stages, right? For example, realizing that communication skill matters and people who communicate well end up getting jobs. And say in IISc, different teaching styles, be it Professor Vittal Rao or Professor Sundar Rajan and so on, very different styles, interactive and very engaging teaching styles and so on. Very interesting aspects that is like a take home. I mean, while working at Mercedes, got opportunities to look at team building, personality, and which is sort of related to some of the problems we looked at later. Teaching in government schools, volunteering, and looking at some of the problems where maybe AI could be applied and so on. And at EDAP, building systems that work in the real world, I think that is one of the theme that was very important. Not just build systems or not just propose some theories, but also towards systems that work in the real world, right? So that is something that was an interesting take home for me. And during postdoc, got lots of opportunities to travel across Europe and collaborate with different institutions, and that could help later in the career. And particularly related to this, which is where I spend most of the time during my PhD on meeting analysis, where previous to, say, when automatic analysis technology was not available, people used to look at, say, two people interacting, right? So there is somebody speaking and somebody else, saying something, right? And people used to look at, say, frames at, say, 1 second, right? And annotate if the eyes are open, closed, head is, how the head is, how is the gaze, and so on, right? So very cumbersome process of analyzing human-human communication. Here it is a dyadic communication, and it is quite cumbersome to annotate at every frame the non-verbal behavior, right? And apart from, say, the verbal behavior, the non-verbal behavior forms an important channel of communication. And many a times it has been observed through several years of literature, research in psychology, social psychology, personal psychology, and so on, that in terms of both perception as well as expression of, say, emotions, your personality traits or relationship between people, expectations, maybe a student who's a good student versus a not so good student, and so on. This automatically happens, right? We transmit that information automatically, and we are many a times unconscious about it as well, right? So this is to establish the role of nonverbal communication in communication, and its form takes different forms, right? Be it expression, eye movements, head movements, and so on. And thanks to the recent, progress in multimedia analytics, we are able to automate this process of human observation by maybe we can call it behavior tracking. We can track behavior in real time, and we can do it automatically using computer vision based methods. And these methods work quite robustly, right? As in different illumination conditions, different pose views, and so on, right? So this has been a very positive development. And thanks to this development, that we can not only track behavior, we can also start to build some models which is from behavior to perception. If you behave this way, maybe you will be perceived as this way, right? Maybe you'll be perceived as a dominant person, right? And sometimes this the whole concept of somebody being dominant or having a certain personality emerges maybe sometimes at a utterance level or at a interaction level. For example, these emerge over a long period of time, whereas say affective state of a person, whether they are sad or happy, that might emerge at a much more shorter utterance level time frame, right? And here you have behaviors which can be characterized as say different facets of the nonverbal behavior, and all of these are one can try and extract them automatically, right? So an example of this work was the work that we did on dominance prediction in a group interaction, where you have a meeting room, and this meeting room had cameras on top, audio sensors here, right? And so on. And you have 4 people, A, B, C, D, and you can look at who talks the most or who interrupts the most, who gets the visual attention, and so on. And this way, you're able to
very understandable. Clearly, your research and ours heading in the same direction, and the only thing that I saw missing from your research that we found was this ability to find the doggone thing when you need it.
Yes, that's true.
So, but that's okay. That's why we're all here at the table, so that if we think of it and our research indicates certain things. And
this was back then, right? This was back then. And soon after coming here, we thought, okay, what could be some problems that we could look at, right? And given that this requires a huge setup, maybe a meeting room and sensors and so on, so we did not have anything. So we said, okay, let's start something simple. Let's start something dyadic. So you have 2 people interaction. Let's look at 2 people interaction, and let's look at something that I was quite passionate about, maybe to characterize communication skills. Maybe if we can assess communication skills, and maybe also maybe give feedback about communication skills. So that is how we started. So one of the assumption, the working assumption here, for example, who is a dominating person, right? So the assumption is if humans agree that somebody is a dominant person, that could be a valid ground truth for a machine, right? So it is. So there will be certain situations where there is no agreement, right? And in that case, we don't even try to model it. If it is, yeah. Thanks for human data, yes, and that is the ground truth, yes.
Very understandable.
So we started to look at multimodal AI for interviewing. So interviewing is a specific dyadic interaction, 2 people interaction. And we had Soumya, who was the first PhD student who contributed really strongly to this line of work. And the first thing that we did was we have these asynchronous video interviews where a question can appear and a person can give an answer. And these interview platforms are now very common. For example, MathWorks tries to ask students to give interviews in this format, right? Where interview happens in this platform, and then the videos are subsequently rated by somebody else, right? So the thing that we did was, okay, these are emerging approaches or platforms. Should we not benchmark it with face-to-face interviews, which are well studied, but then they may not be, in some sense, I mean, they don't scale up so well, right? Because you cannot do interviews anytime, anywhere, whereas these platforms can allow you to do interviews anytime, anywhere. But then these are probably not they're not social in some sense. You have a person on the other side. It's much more social, right? So so we started to look at how can we benchmark these emerging platforms with respect to the face-to-face interviews. And so in this work, what Soumya did, so she collected interviews, close to 100 interviews, both in face-to-face and interface-based conditions. Same person appears in both of these conditions. And we have, on one hand, the rating by humans, which is sort of the ground truth in terms of, say, good versus bad communication skill, let us say. And you have automatic features which could be extracted from the video, be it from speaking activity, prosody, visual, lexical, the words they speak, and so on. Right? So you have these. So this is like a multimodal classification task, right? You're trying to use some of these features which come from the video of a person who's giving the interview, and then you're trying to predict if the person is a good or a bad communicator, right? So this was the first attempt that we had, and what we could see was there were some slight behavior differences between the two settings, and we also could see that, for example, if you use manual attributes, you could predict, say, till 90%. If you use automatic attributes, you could go up to, say, 80%. And this was something that was similar in both settings, right? Both in face-to-face settings as well as the interface settings. So, so in terms of our contribution, one of the main contribution here is to benchmark, right? To benchmark these interface-based interviews with face-to-face interviews, right? And subsequently, we also, so in the first work, yeah. So that anyway we do. So that we anyway do. Yeah. So Professor Sridhar's question was, why didn't we why didn't we compare within the interface setting itself, manual and automatic, right? So that we anyway do. Manual and automatic comparison, we still do. For example, prediction using manual attributes could be like 90%, and using automatic is 80%. And this, we are also trying to do it in both settings, face-to-face interviews as well as in automatic, to show that the automatic also is, I mean, you can, even in the automatic setting also, you can do as well as face-to-face. I think that was our main point to make. Yeah. So we had ASR. So we had in our we had a manual. In fact, we manually transcribed as well. We did automatic speech transcription as well, and we showed the results because of ASR as well. Yes. Yes. Prosody. Yes, yes. So that is captured, no, in prosody. So there is lexical, there is prosody as well. So the features include prosody, pitch variation, and those type of. Yes, yes, yes. So those are also included. So speaking activity could just measure like how much time the person speaks, say activity versus no activity. It's like a binary sort of thing. Prosody captures the. So there were there are a set of a bunch of prosodic features which are fairly standard. For example, mean standard deviation of pitch, loudness, and so on. So there is a set of features which are fairly standard. Yes, agreed by the speech community. Yes. Okay. So so then what we did was here in the previous work. I mean, in terms of a feedback for the person who is giving the interview, it was not so clear, right? In this work, we try to make that. I mean, in terms of giving some actionable feedback, be it both positive and negative, and somebody can get not just one feedback but many feedback as well. So we just posed it as again a classification problem, or multimodal classification problem. But now it is to classify whether you should give this feedback or not, right? And you have a bunch of feedbacks that can be given to people, right? So actionable feedback. And then Soumya's other contributions also included a couple of papers in multimedia tools and application, which is a very good venue in terms of, say, in multimedia itself, in Google Scholar metrics, it is the top venue, right? And so she summarized her work, whatever she has done, in one of the papers. And then we also reviewed this area of multimodal assessment of soft skills in social interactions. eventually, she also did one work where she took some of these models from the lab and tried to run it on some data collected by startups, which is in the wild, right? So a couple of startups with whom we worked with, we tried to see how well the model sort of generalizes, right? And we found that the generalization is reasonably good, and they were happy to use those models for some time. Okay, so this was her contribution. And then in between, we also got a couple of projects from CARE, which is on indoor surveillance, and Bharat Electronics, which is on traffic analytics. Indoor surveillance is definitely human-centered. Here, it was not human-centered so much. It was about vehicles and speed and detecting autos and so on. But this gave us a very good experience about building systems that work in the real world, right? So we have been always trying to build some baselines, maybe through projects, right? For example, here, face recognition systems and so on. But that gives us lots of confidence in terms of, say, yes, we build something and it will work in the real world. And then came Pooja Rao, an MS student. She was interested in text, and she tried to compare, for example, the spoken interviews versus written interviews, or interviews which are typed, maybe which can be useful in certain applications where the bandwidth is low. You can have a written interview, for example, right? So we wanted to see how is this comparison between spoken interviews and written interviews. So that is what she did in the first place. Then she, I mean, when we interacted with the startup companies that I was mentioning, one of the feedback from them was the AVI setting, where you have question appearing and then somebody trying to answer. That was a little monotonous, right? A question appears, you give an answer, again another question appears, you give an answer, but then it is not engaging in some sense, right? So what she attempted to do was, I mean, why can't we create some sort of a follow-up question, right? So given that I have asked, the platform has asked, what is your strength? And the person has replied, say, something, he has said something about his strengths and so on. Can we ask a follow-up question, right? If you can ask a follow-up question, so which means that you have to do a real-time processing, you have to get a paragraph, right? And then you have to ask a follow-up question, right? So the whole thing has to be orchestrated in a real-time fashion. And it should also make sense, right? It should not ask some arbitrary questions, right? So we ended up collecting a data, which is in the form of question, response, follow-up, right? We did a data collection process where we had the question and response, and we sent it out to people and got the follow-up question, right? With that, we fine-tuned a GPT-2 model, right? We fine-tuned a GPT-2 model and started to generate follow-up questions in the text form, right? Once we have the text form, then you can build a system around it to show that it works, right? So that is, we called it the Maya system, which is an interviewing system, right? And yeah, please. Correct. So right follow-up versus not right follow-up. So that was only, I mean, along with the language prediction loss, we had this one other loss, which is a right follow-up versus a not right follow-up. And these were some of the generated follow-up question. And of course, the human generated follow-up questions would probably be even better, right? But at least the questions that were generated were plausible follow-up questions, right? May not be the perfect follow-up questions yet, right? But then there are, what do you say? There are ideas which are like the newer ideas about reinforcement learning, human feedback, and so on. So this is a very good case for that, right? You build something on top, maybe we can improve it further and so on. So this was a very plain fine-tuning that we did, right? Okay, so these were the two losses that were there: next sentence classification loss and the language modeling loss. And then came Kumar Shubham, an MS student who looked at our previous problem, which is where we have tried to compare face-to-face and interface-based. And so these two were the settings that we had done before. And it so turned out that that's when we established a collaboration with Professor Marian, who is considered as one of the top psychologists living around now. So we got an opportunity to collaborate with her. She's in University of Lausanne. So I managed to travel there, and Kumar Shubham also managed to travel there. And we tried to do something which is, say, acceptable even in the psychology community, right? So what we did was we had this interviews done in these three settings: face-to-face, avatar, as well as platform. So avatar is something like this. So we have an avatar which asks questions to the interviewee. Still, the follow-up thing is not here. So it is still a plain vanilla method where there is no follow-up question, but the questions are asked by an avatar. Instead of just a plain interface, we have avatar. And we also, did the study where you have participants from Switzerland as well as India, right? So just to see how generalizable are results and so on. And so this work Kumar carried out while he also traveled to Lausanne for a few months, and this was well appreciated. And this whole work we later, wrote it up as a paper, which eventually got published in a psychology venue, right? So this is a International Journal of Selection and Assessment, and together with a few other collaborators, we managed to publish it in a psychology venue. And subsequently, we also collaborated on few other things. I will talk about it later. This was another work that came out through this UNIL collaboration. And thinking about models and so on, right? So around the time that Kumar was here, right? So what was becoming popular was the GAN approaches, right? So here's a discriminator, right? Where you have an image as input or a video as input, and you classify, right? For example, you classify objects in an image. There were models which were encode decode type of models. For example, where image is an input and output could be an image itself. For example, you could be doing an image denoising, or you could be segmenting an image and so on. And if you think about this as an encoder, this is a decoder, right? It could be a decoder, or one can think about it as an interpolation, right? You have a vector here, and then you are interpolating and eventually getting a image, right? And so this can be thought of as a generator, right? For that matter, you have a vector and you have an output, which is an image, right? And around this time was when the adversarial approach became prominent, where you have a generator and a discriminator. A generator generates images, right? And this generator could be something like this, right? And now, if you have a real sample and a generated sample, you can build a discriminator which will find faults in the generator and give it as a loss, and helps to improve your generation, right? So these are what are called generative adversarial networks. And what Kumar tried to do was he took a GAN, or a generative adversarial network. It is called progressive GAN, or even a style GAN for that matter, which are say standard GAN networks, which are trained to generate images of a person, right? And he basically tried to do this reward engineering, wherein given a face representation in the latent space of a GAN network, right? How can we traverse, right? So that maybe you can do some semantic manipulation, right? What do we mean by semantic manipulation? So by semantic manipulation, we mean, for example, given an image given an original image, can you make it older or younger and so on, right? So can you start to do this semantic manipulation? And these are results where these are some of the images which are from the network itself. So these are not real world images that we are starting with, but an existing image, for example, and you do the manipulation. And the first two are from progressive GAN, interface GAN, which were the baseline methods. And we showed for a couple of approaches in, say, using RL, for example, you can get the results better in terms of manipulation, right? So this was one of his, say, second work that Kumar did. And subsequently, he also extended it to an interesting use case where we can give images as input, right? Previously, we could not give images as input. And for an existing image, we were able to do the conditional manipulation, semantic manipulation. So here we can give images as input, and then from here you can make them younger, change the gender, smile, maybe remove the smile, and so on, right? So whereas here in this case, it's slightly different, right? Maybe from here, right? It starts from here, and you can make it age, change the gender, smile, and so on. Okay. So this was a very interesting application for us, because from the psychologists, we got this as a problem statement, right? So can we start to create these controlled changes in images, and then they can be used as stimulus for psychology experiments, right? So this was something that they really liked in terms of the contribution. So around the same time, it's not that we were the only person working on this. Around the same time, there are several other contributions, but we had something that we can work on in our lab, right? So we have full control. We can change the problem statement, and we can use it. So that was Kumar's contribution. We also had a couple of PhD theses along with Soumya. For example, Annapurna, who worked on automatic essay grading, where you have maybe a page of, say, essay that somebody has written, take a picture on your mobile, and maybe can you give a grade, right? So this was Annapurna's work. So a couple of works I'm not emphasizing because our team is interviewing, so we'll go back to that theme, but wanted to mention their work as well. For example, Annapurna eventually she ended up collaborating with a petroleum agency which conducts they conduct the essay competition, right? So they were kind enough to give us some data, and we ended up analyzing the data, and hopefully it will lead to an automation of essay grading and so on. But now I think there's a lot of literature around OCR and essay grading that has come, right? But we were thinking about this problem mainly to look at maybe schools and try to do this as a task, right? And her work, one of her work was published in a very good venue. So this is a top venue for this kind of work. And this is a top venue in AI, for example, under AI category, expert systems with applications, right? And then Chinchu, she also, who graduated 2022, she worked on, so it's a slightly different problem, right? Presentation in classrooms, presentation in online teaching, for example. So she tried to compare these two settings, classroom versus online setting. And two problems. One is presentation skill and engagement. Presentation skill is about the observing the presenter and doing ratings about the presenter. And then engagement is about having a camera on the audience, looking at the audience, and trying to infer if they are engaged or not, right? And one of her paper now has 96 citations, which is really great to see, right, in terms of her work, and also a couple of journal publications as well, right? So another very, very solid work from the lab. And computer and education is considered to be the top one in educational technology, for example. Okay, so let's go back to our interviewing team. We have this Maya, which can ask a follow-up question, right? So from here, we try to extend it in a couple of directions. One of the extension of Pooja's work was to look at what is, somehow trying to, measure the affect of a person who is speaking, right? And then trying to generate a follow-up question which sort of understands the affect, right? For example, if somebody is angry, right, and you have a customer care agent, right? You don't want to be angry. If somebody is angry, say the customer, you don't want to be angry, right? So if you can learn from data where in a similar setting, if somebody is angry, the response of the agent should be in some sense trying to calm down and so on, right? So we tried to use an existing data where you have the affect of two people available, and we tried to incorporate it as one of the laws, which is the affective loss that we added, so that the responses from the follow-up, response generation is somehow it sort of acknowledges the affective state of the participant, right? The one with whom you're talking to, right? So this was a work funded by Accenture Labs, and we eventually published in a workshop at ICPR, okay? And then the second extension, which is the UPSC interviewing platform. This was done in 2021, and there was a person called Dr. Kedar who looked at our follow-up question generation work, and he made a connection saying, okay, yeah, this looks good. I mean, we are working at India for IAS Academy on actually giving interviews to people, and we are not able to give mock interviews to several students because we have a very limited bandwidth, and these people have to travel all along from some rural place to the city and take up these mock interviews, and it has a cost and so on. So maybe you can try and see if you can apply your work to the UPSC setting, right? So that's how we got started. So we built this UPSC interviewing platform, and here is a video of it.
Hi, and welcome to this demo of Margadarshi.
So as you can note, this system is like you can go to a browser, right? And you can log in and get started.
A cognitive interview platform.
Right?
This can
you
create
can choose, say, what you want to
targeted
do.
at UPSC candidates. It offers interviews practices in various different topics, and also offers a complete mock.
So you can do pick any of these topics that you want to pick up for your interview, and then
conduct. When a mock interview scene is loaded, notice that it is a complete 3D.
So we try to give it as a full experience, right? So you have the experience, of people actually entering the UPSC office and giving the interview and so on. So we try to make it as realistic.
And candidates can navigate around to get the feel of how a real interview experience would be. They can enter into the building and wait in the lobby. And when they're ready, they can choose to click and proceed towards the interview room. The bottom during the course of the interview. The important part is the entire interview is also for an assessment as well later. Click, enter the interview room and greet the panel. Hi, ma'am. Good afternoon, sirs.
Please sit down. Who is your inspiration as a civil servant? Why?
There are multiple civil servants who are an inspiration.
So as you can imagine, so this was, these avatars were something that was already available in a Amazon platform that we chose to use for our application, right? And it involved a little bit of integrating the video and the graphics and so on. But essentially, if you see the graphics, the avatars are a very basic avatars, right? They don't, for example, they don't do a lot of gesturing, they can't express, and then it's a very basic avatar. But this is what we had on the avatar front. The key point of the contribution was on one hand, follow-up question generation, which was primarily behavioral interviews, right? From there, we could sort of put it in a in a UPSC setting, and broadly the follow-up question generation mechanism worked there as well. We needed a data from that domain. We got the data from that domain. We had to put some checks and balances so that, for example, the question is at least of a certain length and has certain properties and so on. So those pre-processing, post-processing we did, but essentially it worked in this scenario as well. Okay, so this was our technical contribution, right? And thanks to support from the institute and Mindro, we built this tool, and then we went to India for IAS Academy, and we created a MOU where they use this platform. And it so turned out that they used it in their setting. We got some feedback, we improved it further, right? And then eventually the ministry, the Minority Affairs Ministry, they got excited and they gave an order to this India for IAS Academy for 4,000 licenses, which was something that we felt was very good, because the work from the lab has eventually got to the field. And then those 4,000 licenses were given to people across Karnataka, and they used this system and benefited from it, right? So this was one of our strong contributions from the lab, where it's not only about publications. Of course, publications are important because we want to have works which are validated, right? But then something that goes out of the lab into the real world, right? Okay, so any questions so far? Anything in particular? So now we'll change gear and move towards vision for graphics and so on. Yes.
They were from a bunch of available questions, or they were also randomly generated, the follow-up questions?
So, so the format is, there are questions which are predetermined questions, and then you insert one follow-up question. So, so there's only one follow-up question. So one can go two follow-ups, but we found that one follow-up is a good choice.
Okay.
Yeah. Okay. So, so as you just saw, right, our platform in terms of the agent behavior is quite basic, right? But then in 2014, there was a seminal work where at USC ICT Institute, which is affiliated to University of South California, right? An amazing work came out, and they had a bunch of, interdisciplinary researchers, vision, graphics, psychology, and so on. So they had created what is called the Simpson site, which is shown here.
I'm not a therapist people and would love to learn about you. Feel free to tell me anything. Your answers are totally confidential. Are you okay with this?
Yes.
So, how are you doing today?
I'm doing well.
That's good. Where are you from originally?
I'm from Los Angeles.
Oh, I'm from LA myself.
So here you can observe that on one hand is the analysis, right? A multimodal analysis of a person. Maybe it is a therapy session, for example, right? And here is the avatar. And you can observe that the avatar has gestures, it does nodding and several behaviors, which are much more towards, say, realistic. In terms of realism, it is much more realistic, right? Appearance-wise, in terms of the model, in some sense, it's still not a high poly avatar, but these are terminologies I've picked up, Jaya, in the recent few years. So this is still not, say, a high poly model, right? But still okay. The main contribution of this work was to be able to show this system in real time and be able to control these behaviors, behaviors of the avatar and so on, right? So this is a very seminal work, and we got interested, right? And if you see this whole system, has different components, right? On one hand, you have this multimodal analysis, which was shown on the left side. You have the dialogue, which is what is the speech that the text that the avatar is going to speak, which is in itself is a big problem, right, to solve. And then you also have another problem, which is the multimodal synthesis problem, which is given that you have decided to speak something, what should be the behaviors that go along well for the thing that you would like to speak, right? So this is the synthesis problem. So analysis and then synthesis. So we said, okay, we have to look at this synthesis in order to say build avatars which will have some realistic non-verbal behavior also, not just silently saying something, right? So we got interested, and one of the project which was from Emphasis on Indian Sign Language, so that gave us a very good start. So while people were looking at Indian Sign Language recognition, which is given a video, you recognize what is the word being spoken. Our work is on the synthesis side. We are trying to generate a video of a sign, right? And the typical challenge is you might have videos recorded by, say, one signer and then another signer and so on. But if you have to build a system where there is a sentence and you want to create a video for that sentence, right? You will have one video done by one speaker, another by another signer, and so on, right? This you don't want. So what our goal was to take videos of signers and put it on, say, an avatar, right? One avatar doing all the signs, or one person doing all the signs, right? What is that one person? I'll come to it. But these are the main goals, right? So we want it to be consistent that, say, an avatar does the sign or a person does the sign, right? So we saw that over time, there are these mesh models which were becoming popular, right? A video and a mesh, right? So you can start to have meshes which can fit people and so on. So this is a line of work which is, say, beyond joints, right? Given a person's image, not only can you get joints on the body, which is 2D in some sense, you can start to get 3D points, and these 3D points are dense as well, right? So meshes are basically 3D points which are dense, right? So now you have vision which can predict these 3D points, right? So this was one line of work that was coming, but we tried to take a slightly different approach, right? Where we said, okay, can we look at it slightly differently? Because we had collected a set of data where for 3,000 Indian signs, right? We had an avatar doing the sign, right? So this is something that was created in our lab thanks to this project. So we had that data, right? So we thought, okay, can we somehow reuse that data where you have signs done by, or animations that was created by graphics designers for 3,000 signs, right? So what can we do with this data, and can we do the following, right? We eventually did this, which is from a video, we are able to transfer from a video to an avatar the same action, right? If we can do this in a consistent basis for all signs, then we have avatar doing all the signs, and we can build a system for translation, for example, right? So this is on the gesture. Similarly, for the expressions also, one can do the transfer, right? So how does the transfer work? So the best part was we had this pair data. We have a pair data, which is what you need for deep learning, right? So you have both the joints which are in 3D, right? Because manually somebody has created the animation. So we have the 3D joints, and we also have the 2D joints. So some of the 2D joint estimation methods, they even work on these images, right? So you have a pair data where you have the 2D joints and the 3D joints in some sense, right? And now you can learn a model from 2D to 3D, right? If you can learn a model from 2D to 3D, so this, you can use it for a future video, right? A future video that comes, you have the 2D joints, right? And then from 2D joints, you can get the 3D joints locations, and you can create a video, right? So this was our reasoning, and we ended up carrying this out, and we tried to also compare it with some of the mesh models and so on. And our model performed reasonably well, okay? And that is the video you just saw here. Right? From image, we extended it to video as well. Yes.
Dinesh, one question. We have seen in some of the modern animation film studios, they have these setups where, in fact, I had recently been to one, where they have this setup where they are capturing the gestures of the actor from various angles, and they populate the mesh from that. So how does your work distinguish from them?
Yeah. So so do they have any motion sense? I mean, do they have any motion capture? No. They are only. So there are
I could see lots of cameras.
Cameras, yes. So I think so. The first, first phase, there was a lot of motion capture. So you put a lot of sensors on the body and try to get those joints in some sense, right? And then the next line of work is probably what you are saying. You might have multi cameras and trying to reconstruct a human in some sense, right? So here it is just a single camera image, right? And you are the computer vision works well for getting the 2D joints, right? But thanks to a data set that we had 2D joints as well as a 3D, 3D joints basically, right? Because animators had created it, we used that to do a 2D to 3D lifting, and we could use it further, right? So in some sense, I mean, this is a very, very specific contribution. You try to use our data set to make sure that this avatar works well and so on. But that is whatever you're saying is also an approach, right? Where you have multiple, what do you say? I think I don't know if I have it. If I have it, I'll show you. So a room where you have so many cameras, and then you try to build a very, what do you say, high fidelity avatar of a person, right? Yes. Yes.
So for Indian Sign Language, you don't have the entire, what do you say, spectrum of actions and motions and poses, right? It's very limited for this one. So you don't actually need that kind of high fidelity just for this work.
Yeah. Yes, that is true. Yes. Thank you, Jaya, for saving me. So this work was published in ICCV workshop, which is also a rated venue. And subsequently, so we transferred from video to an avatar. We can also do a transfer from a video to a person, right? Here we see that there is this signer, but we want to replace this signer or any such signers to Shyam, who is this person here, who's an MS student who's doing this work. So, so in this work, in this particular work, we basically used GANs in order to generate the new video, right? And again, this is also a deep learning network, and you can see the output here. So it still has a little bit of distortions, but you get the point, right? We want to do this transfer from the set of all signers to one signer, right? Okay, so this is one set of work, right? And this is just a fun video about transfer, right? What? So this work, when it came, it was very popular. It was called Everybody Can Dance. And here you see from a source, you're able to transfer it onto a different person dancing, right? And it involves, of course, a discriminator which does a post estimation, also a generator which can take the joints and produce an image, right? And it is trained for that particular person. And given a new video, you can get the joints and scale it if needed for a new person, and then eventually use the generator to produce the output, right, which is a video. And you also have losses which make sure that the images that you are producing are temporally coherent, right? So that is another loss, temporal loss. So this is an interesting line of work. There was also this line of work, which is also called deep fake, where
this year I figured we could.
So here you see somebody is going to speak.
Hi, everybody, and welcome to MIT 6S191, the official introductory course.
So here you have a VIP giving an introduction to a course, and you see what happens behind the scenes is basically the transfer of voice.
Hi, everybody, and welcome to MIT 6S191.
Hi, everybody, and welcome to MIT 6S191.
And then
the official introductory,
the final transfer, right, to the person
here at MIT.
So the good thing with this work is transfer, right? Transfer of previously it was a dance, now it is somebody speaking. So we in the lab, we also wanted to see if we can make some contribution, and we were thinking about this from a psychology point of view, where you want to generate controlled videos, right? So basically we use this deep fake idea basically to transfer from an actor to say to some other person, right? And for this you might just need a photograph of that person, right? With that you're able to do the transfer to this person, right? So one actor video. And this way, so our argument was, if you can somehow, if you want to increase the data set, right? Typically you have limited data. You can use this as a way to create more and different stimulus for psychological experiments and so on. And this particular work that I was mentioning before was basically, we explored that idea, right? The idea in 2 dimensions. On one hand, on the video front, you can do this transfer, and the other is even appearance front, right? So you can create a person who is older, younger, smiling, not smiling, and so on, right? So you can explore the full plethora of way in which you can expand the data set, and you can use it. You can do it at a lower cost and so on, right? So this is the work on that. And then coming back to our avatars, right? So there is a bunch of work that we followed. So what I'm going to do in the next 15 minutes, I think I'll conclude in 15 minutes. So what I'm going to do is I'm just trying to sort of summarize the kind of works that are happening in this space, and give you some structure where vision is used for graphics, right? So on the line of work, which is, so what are the things that we need, right, in order to create a avatar that can speak? On one hand, you need to create the avatar itself, right? That is the first task. And then you have to animate the avatar, right? Assuming we have an avatar, right? How can we generate the behavior? So early work, 2004 work, what they did, you have a sentence, right? And then based on rules, linguistic rules, right? You try to assign what could be a suitable non-verbal behavior, right? So this was a rule-based system. A very early rule-based system where based on what somebody is speaking, right, you tend to perform certain eyebrows or gaze away and so on, right? So this is rule-based, very early work. And then subsequently, what is called a VH toolkit, which had this a bunch of behaviors incorporated, right? So here again, you see that any sentence, you try to map it into say interjection or affirmation and so on, and then try to assign a behavior corresponding to that, right? So it's still a rule-based system where given a sentence, you try to generate behavior, right? And in Jinal's thesis, which was defended in the morning, so she had looked at an avatar where there is no nonverbal behavior and with nonverbal behavior with some of the rules incorporated, right? And we tried to see how is the perception difference for interviewees, whether they are in this setting or this setting, right? So this is a comparison that we try to do, and it clearly shows having gestures really is important. Follow-up question is also important. And subsequently, she also looked at this Margadarshi platform collected data set, and where you have communication skill rating that was done, right? And she tried to use lab collected videos, which I talked about before, and try to see how well she can adapt to the new domain, which is from this domain, to predict the communicator good versus bad, right? And we also reviewed this area quite a bit with OpenStream, Lakshmi, Anirban, right? And we saw that the more recent works where the way they worked was slightly different, right? They were data-driven in some sense. You have a sentence that is being spoken. You could have the audio corresponding to that. And then at every frame, you see that the avatar is being manipulated, right? So you have joints on the avatar, and you basically control the joints of the avatar at every frame, right? These are what are called gesticulators. You could control the facial expressions of the avatar. You can learn from data, right? You can also learn from data how you want to listen, right? Maybe not just about speaking, right? You can also when to nod, maybe, right? So things like that. How you can control the frame of an avatar. Okay, so
mankind has always been a.
So here was an interesting moment where the avatars from low poly avatars started to move to high poly avatars, right? So here you can see the kind of detail.
With the human. Well, .com, that in the mouth, the nose, the eyes, the ears, etc. Another key goal of the simplified blockout is to establish correct.
Very
think of it
realistic
eyes,
which coming out of some of these
from the sculpture. It's
so
similar to a chia pet. We can grow, comb, and
we wanted to
propagate their online to impress our social media.
How can we easily create, say, very realistic avatars? Or if you have highly realistic avatars like this, how can you generate behavior on that, right? For example, animation.
Hello, Michael here from Small Robot Studio. Perspective on the left, really be only hitting variations of the half width, but you'll get most of what.
Okay, so the main points for the previous video, the main point is it takes a lot of effort for manually creating avatars. In order to create animations, you have to group some of these points, right? And then try to do an action and so on. Creating animations is also a very intensive process, right? So what we have seen so far, which is in terms of talking body, right? What are the options that we have? We can manually create the avatar, which is what an animator will do, right? We can create an animation by either doing it manually, right? Maybe somebody running, you have to create it manually, or you can have a video of a person running, and then you can do a transfer, which is what is something that we saw some time back, right? And then you can do a orchestration. I mean, if you have this word, then what should I do in terms of nonverbal behavior? You can have it rule-based, or you can have it data-driven, right? Which is what we saw some time back, right? Every frame you can predict, and then you can drive an avatar, right? So this is what we have seen so far. But what is interesting is the next 3 steps, right? Which are the newer trends that has come up. For example, can you use vision for creating avatars, right? So for example, this work on neural head avatars is in that direction.
Neural head avatars, which is a novel approach for optimizing photorealistic avatars of the human head. Our method creates an explicit shape model that provides geometric consistency when being rendered from novel viewpoints. Together with our novel dynamic texture function, we've obtained an articulated, photorealistic digital counterpart of real subjects, which is useful for a range of multimedia applications. to optimize the avatar from a monocular RGB video.
So as you can see here, given a video, you can estimate the mesh, which is a video problem, right? We can estimate a mesh, and these are parametric meshes. So they are controlled by some parameters. For example, the shape, what is the other parameter? Say if the expression, pose, and so on, right? So you can have these controlled, right? And you can fit a flame model, which is a parametric model, to a given video, right? That way you can get a coarse estimate. It is not still modeling the hair and so on. In the subsequent stage, you will see that they are able to model the hair.
This enables view and expression-dependent effects and allows to plausibly synthesize the inner mouse region, for which no explicit geometry can be reconstructed.
Right? So what is the main point that wanted to drive? So the main point wanted to drive is, so now you could have an automatic avatar that can be created using video. You can create automatically an avatar, which is an explicit representation. So you actually have an avatar which is explicitly modeled. And then once you have that, you can do either rule-based or data-driven for the animation. And these are what are called neural head avatars. So good. I mean, this is one good option. What is the other option? The other option is you could also have an image, right? You could just have an image and make that image either do lip sync or move the head, right? So that is also an option that is coming up, which is starting from a 2D image, you can generate the final video, right? For example, the 2D image, you can do prompt engineering and get a person, right? Or you can use a GAN, manipulate and get an image, right? And this is thanks to Divyam and Anirban. You have some of these options where on one hand, you have a transfer, right? This is the right side is transfer, where somebody is performing some basically talking, and then it is transferred to these people. Or you can have an automatically generated video given a sentence, right? Given a sentence, can you generate the, head? Can you predict the head movement? And can you predict the mouth movement? And eventually generate these videos, right? So these are generated videos. These are transferred videos. This is an image that is coming from, say, Midjourney. This is an image that is generated by a GAN. And this is a real world image, right? A photo of somebody. And here you also have, just for the men, you have a neural head avatar as well, right? This avatar was created from video, okay, which you saw sometime back, right? So how does it look?
First, I will need to know the reference number of the police report that documents the fact that a theft from a vehicle of an out-of-view mobile phone occurred on September 13, 2022.
First, I'll need the reference number of the police report that documents the fact that the theft from a vehicle of an out-of-view mobile phone occurred on September 13, 2022.
So
first, I'll need...
in terms of the message, now you have, instead of creating an avatar, so you can create an avatar and animate it. That's one option. You also can create a character for yourself. The way you want, either using prompt engineering or a GAN or a photograph that you want to start with, right? And you can start to animate both the mouth and the head, right? How you animate the mouth, for example, you can use works like wave to lip, which is basically trying to handle the dubbing problem, right? Where you have somebody speaking in English and you want to make them speak in Hindi, right? So you can basically have a data set where you have both audio and speech as well as the image frames. You can learn what is a good synchronization, right? How should the mouth be? You can have some losses, and you can basically do a dubbing, right? Here, there is, you don't have to worry about the head movements and so on, because anyway, you have the original video, right? But then in a generating form where you just have a sentence and you have to generate the head movement, you also have another work, which is like audio to head, where you have a single reference image, you have a audio, right? And you can predict the head motion, right? And you have a dense head motion that is being predicted. And then you can have a generator, just like you have a joins to a image, you can have this dense motion prediction. With this, you can generate an image as well, right? So that is how some of the videos on this side were generated, right? From an image, you can make the head talk, right?
First.
Okay, so we are almost towards the end. So what is the last trend?
Dinesh?
Yes.
One quick question. So for the earlier thing,
which one?
Yeah, this one. So for these kind of things, sort of loss function they use, is it CTC or?
For the audio to head, I think they learn, they have a training data where the actual head, they have the actual head's parameters. And so on that data set, you can learn to predict, right? You can learn to predict given this sentence. And so in training data, you have a sentence, it's audio, right? And the head parameters. Now you have a new data where you only have the audio. So in that data, you learn a model. And through that, so the error could be just the error between the head parameters of the actual versus what you predict, right? And you learn it in the training data.
Yeah, just the square error.
Square error.
But for that, the output needs to be perfectly synchronized with the thing, right?
Yes. So I think
why don't they use CTC kind of loss for this? That will be a lot more robust, isn't it?
CTC, I haven't seen.
Is it? Okay. But I thought CTC was quite common in the speech scenario.
Speech setting, but I think in this they did not use. They just use. Okay. Yeah. Okay. So in the interest of time, so I'll quickly move. What is the fifth trend? And I think this is also a trend which is interesting for computer vision going forward, which is basically nerves, neural radiant fields. So what do neural radiant fields?
Hello there. Task specifically look at the ship.
So what is the idea here? So the neural radiant fields, what their the approach is, given say few views of a scene, right? Say given a scene somewhere here, and you have few views, can you implicitly construct the 3D world? And then you ask to render for a different view, can you render it, right? And this render, you can go anywhere and you're like a camera who's capturing the 3D scene. So you're able to capture what is ahead of you, right?
For example, right here.
So this whole thing is constructed by the algorithm, right? Given few views only. And it is an implicit model. You're not constructing the mesh and so on. It is a neural network. It is implicitly constructing this, right? And one such technique was used to generate.
Hello, thanks for watching the supplementary video for our paper, Real-Time Neural Radiance Talking Head Synthesis via Decomposed Audio-Spatial Encoding. Our method is person-specific and only needs a 3 to 5 minutes monocular video for.
So that is the last approach. So all these are implicit, these two, and this is explicit. And looks like there is a interesting, interesting time ahead where you will have these talking heads getting better and better, which is basically only talking, right? Maybe slowly you will start to have models for listening, not only conversation, but doing any action, right? So I think it's a interesting, if you project, things are going to be interesting in the future. So just to conclude, our spectrum of work has been on communication skill. We have extended it to autism, exercise, activity understanding, and so on. So several students have started to contribute. We have managed to collaborate with very good labs, and over the time have been funded by very good funding sources. Okay, so I'll conclude here with acknowledgement from, two students, colleagues, staff, institute, funding sources, and collaborators without whom this would not have been possible. Yeah, thank you. No questions. People are tired. I'm sorry, it was a little long. It's good. All questions answered.
Sorry, I can't hold back a quick joke. If
Please.
you are capturing our gestures, You will not find us sleeping.
Your engagement level is 50-50.
I would say it would be high for everyone. Thank you.
Thank you, Sujit.
Thank you for the excellent talk.
Thank you.